All right, welcome to chapter 2, solving two-step equations. This chapter is really, or this section, this whole chapter is easy, but this section is the easiest, I would say. Just start off by some examples. Basically, the concept here is you want to isolate the variable. So let's say we have x plus 3 equals 5. It's quite simple. I'm sorry, 2x plus 3 equals 5. So this is a two-step equation, okay? So 2 plus 3 equals 5. You subtract 3. That's our first step, as they say. This goes away. We get 2. 2x equals 2. Our second step would be dividing by 2 on both sides, and we get x equals 1, right? So this is our final answer. So let's see. Step 1 and step 2. All right, so you see step 1, you see step 2. First step was we subtracted. Second step is we divided. In other cases, you might add first and then divide, or you might add first and then multiply, or whatever you have. But like I said, I'll go over it with you, and you shouldn't have anything to worry about. All right, next example. We have 10 equals x over 4 equals, I'm sorry, not equals, plus 2, okay? First step, we're going to subtract 2 on both sides. First step, 8 equals x over 4. And then because we have this fraction right here, we're going to multiply by 4 on both sides. This becomes 32 equaling x. Final answer. Bam. First step, second step. In your check yourself, what I want you to do is I want you to do first step, second step, and then label what your first step was, or not label, but just circle what your first step was, circle what your second step was. It's just good. It's a good work ethic. It also shows your work for your teachers or whoever wants you to do it. Okay, perfect. It's like a good what's the word they have? It's a good trait. It's a good. I don't know. If it comes to me, I'll let you know. Anyways, next one. Let's do another example. I'll do a hard one. Let's see. Here we go. If we have, I want to do a fraction. Here we go. 5 over 7x plus 1 over 7 equaling 3. All right, this is fun for me. Maybe not so much for you. But what we're going to do is this might be a 3-step problem, okay? So first what we're going to do is we're going to subtract 1 over 7 on both sides. First step. Now, we can't just subtract 3 minus 1 over 7, so what we have to do is 3 minus 1 over 7. What I'm going to do is I'm just going to write it out for now so we can see the step, okay? So 5 over 7x equals 3 minus 1 over 7. Now, 3 minus 1 over 7 we can't do just like that, so we have to convert it so they both have similar denominators. The way we do that is we both have a denominator of 7. This one just stays the same, so that just goes right there. Bring down the minus sign. The 3, now we have to have a denominator of 7, yes? So what we need is a denominator of 7. We multiply the denominator by the whole number. 7 times 3 gives us 21. And now we have our, we can work this out now. So now we have 5 over 7x equals 21 over 7 minus 1 over 7. Now, there's going to be 2 steps that I show you, or 2 ways to solve it. One is for the more just a regular way to solve it, and the other one is for just when you just recognize it like that, okay? So we have 5 over 7x. This is the regular way, okay? So 21 minus 1 over 7 becomes 20 over 7 equals 5 over equals 5 over 7x. Multiply 7 on both sides. Guess what? It goes away on both sides. 5x equals 20. Therefore, another step would be divide by 5 on both sides. X equals 4. Bang. There you go. Now, that was the regular way. The other way is you can just notice if they all have the same denominator of like a number, whatever the constant is, whatever that denominator is, it can just go away. It can be eliminated, and you will have the exact same answer. So if we had all this, and we move it over here, 5 over 7x equals 21 over 7 minus 1 over 7. Guess what? It's the exact same thing, like I just said. 5x equaling 21 minus 1. 21 minus 1 gave us 20. Excuse me, let me back up real quick. 21 minus 1 gave us 20, equaling 5x. Divide by 5 on both sides, and guess what? 20 divided by 5 still gives us 4. Same answer here, same answer there. Bang. All right, so this section is called solving multi-step equations, which is like 2-1, but more steps basically. All right, so I'm gonna give you 3 examples, and you'll be able to get it because it's quite simple. Okay, so one thing that you want to know is what's called combining like terms. Okay, combining like terms is basically if we have, think of it this way, it's basically fancy wordage for if you have 5 carrots, not carrots, let's say you have 5 quarters, I'm going to abbreviate quarters with Q, and you subtract 2 quarters, I'm abbreviating with Q, now you have, guess what, 3 quarters, okay? That's what quote-unquote combining like terms is, okay? Same thing, basically what you do is you subtract or add or whatever they want you to do in that given scenario and combine like terms, whether you're adding or subtracting, okay? And what you also need to know is distribution, but I believe we went over that already. If not, distribution is like if you have A, B plus C, A, B plus, so basically you multiply it into both constants. A times B gives us AB, and this will give it AC, okay? Given an example, let's say we have X, not X, let's say we have 5X plus 4 equaling 16. Multiply the 5 in, we get 5x plus 20 equaling 16. We subtract 20 on both sides now. That says 12, not 20. 20 on both sides. Now we get negative 4. 5x divided by 5. Now we have on both sides, excuse me. And now our answer is x equals negative 4 over 5. That is an example of a multi-step equation that I came up with off the top of my head. All right. Another example. Let's say we do... I grabbed my examples from the Check Yourself. So, just if in case you were wondering. All right, let's see. Okay, easy one. 4x minus 2x equals 18. So this one is quite simple. All you gotta do is combine like terms, divide, and you have your answer, okay? So 4x minus 2x gives us 2x equaling 18. 4 minus 2 is 2. That's why we got that. 2x equals 18 divided by 2 on both sides. And now we have x equaling 9. Another example. If you have 7x minus 3x minus 6 equaling 6. Add the constant to both sides so we get the constant and the variable separate. So now we have 7x minus 3x equaling 12. We know that 7 minus 3 gives us 4, so 7x minus 3x gives us 4x. And that equals 12. Divide by 4 on both sides. X equals 3. And of course, if I'm going way too fast, you can always rewind this video over and over again as much as you want, and or you can send me an email to tjstutoringportal@gmail.com. Another example. Let's say we have, this one, I like that one. 1 over 2 plus 7x over 10 equals 13 over 20. Okay. So we're going to move the constant over here, but what I want to do first is get all the denominators the same. We want the, I believe it's called the least common multiple or the greatest common factor, whatever they call it. The GCF, the LCM, one of those abbreviations that means the denominators get to become the same, okay? So, what I'm thinking is, do we want to do that first or do we want to do that last? I think we want to do it last, actually, in this case. So, keep that in mind. We're going to subtract 1/2 on both sides. Now, going down, we have 7x over 10 equaling 13 over 20 minus 1/2, right? Now, 13 over 20 minus half, that can't be done as is. So what we need to do is get the denominators to be the same. So 13 over 20 minus, we need a denominator of 20. Therefore, the numerator must be 10 because we're multiplying by a factor of 10 over 10 right here, okay? So we multiply the 10 by the numerator and 10 by the denominator. Therefore, that gives us our 20 in the denominator. So now 10 times 1 gives us 10. If you're wondering where that came from, it came from right here. There's a 10 times 1 and a 10 times 2 right there, giving us this, okay? So now we have 7x over 10. 13 over 20 minus 10 over 20 simply gives us 3 over 20, equaling 7x over 10. Now, this part just is intuition, okay? So if we have 7x over 10 equaling 3 over 20, what we need to do is get the denominators the same, A, or we can just cross multiply B. I'll show you both, okay? Here's cross multiply. See which one you like better. Multiply this times that, and this times that. 7 times 20 gives us 140x, because the x comes along. 10 times 3 gives us 30. Now we divide on both sides. I'm sorry, the other way around. Go with it. Actually, no, take that back. Draw it again. 3 times 10 and the 7 times 20, right? So we get 140x equaling 30. We divide by 140 on both sides, because we want to get the variable by itself. Now, this goes away. We get x by itself equaling 30 over 140. This 0 cancels with that 0, leaving us with just 3 over 14. Option A. Let's show you option B. Option B is if we have 7x over 10 equaling 3 over 20, what you can do is double this one, because we know that to get 10 to be a denominator of 20, all you have to do is multiply by 2 over 2, right? So now we multiply by 2 over 2, 10 becomes 20, and 7x becomes 14x. And remember when I taught you earlier that the denominators being the same thing means we can just cancel them. 14x equals 3 divided by 14, x equals 3 over 14. B. Either way you do it, you'll get the exact same answer. Cool. Alrighty. Alright, now we have chapter 2-3, which is equations with variables on both sides. With this, this is just more practice, really. It's the exact same concept. You get it easily, okay? So let's say we have 3x plus 4 equals x plus 18. So what we need to do is subtract the 4 on both sides, like we always did. This goes away. And 18 minus 4 gives us 14. Alright, now we can subtract this x on both sides, like we were doing before, like combining like terms, right? So now, the 3x minus x gives us 2x. This goes away, equaling positive 14. Now, we can divide by 2 on both sides, and x equals 7. Does that make sense? First step, second step, third step. So this is a 3-step problem, okay? Hence the term, oh, and yes, and then the equation had a variable on this side as well as this side, okay? Multi-step equation. Let's do another one. Let's say we have, let's do that one. Negative 8x plus 14 equals negative 2, 4x minus 7. Alright, multiply the negative 2 in, we get, when I mean that, I mean we're distributing, okay? Multiply that by that and that by that. The negative 2 times 4x gives us a negative 8x. Oh, this is going to be interesting. And then negative 2 times the negative 7 gives us a positive 14. equaling negative 8x plus 14. Now, if you've already noticed, don't say anything. If you haven't noticed, I'll keep going. Let's say I subtract 14 on both sides. That means that goes away and that goes away. Guess what? I still have this. If you still haven't noticed, don't say anything. Divide by negative 8 on both sides. That goes away, that goes away. And now we're just left with x equals x. Now, I didn't plan this, just letting you know. Now, in this scenario, this is what's called all real solutions, because any number that you plug into this equation will give you a true statement. Because if I plug in 6 on the left-hand side, if I plug in 6 for x, it will be the exact same answer on both sides. It'll equate. So this is what's called all real solutions. Any number you plug in, whether it's 5, whether it's 20, whether it's 20 billion, any number you plug in, you will get the exact same. So this is all real solutions. And all real solutions can be labeled as this. It's essentially, I'll do it again, an R with a second line next to it, okay? I draw it fancy like this. Nothing big. So if you see that, that's what it means, okay? Let's do another one. One more. If we have 6x plus, equals 4x plus 5, we distribute. Therefore, this goes to that, and that goes to that. 4x plus 20 equals 6x. Now we subtract 4x on both sides. We get 2x equals 20, and we all know that 20 divided by 2 just gives us x equals 10. Bam. There we go. Alright, welcome. This is Ratio and Proportion to Chapter 2, Section 4. Basically what this is you know when students always ask, oh my god, when am I going to use math ever in life? This section will be an example of when you will use math in your life, okay? So, one thing you need to know is what a ratio is. A ratio is a comparison of two numbers by division. The ratio of A to B is also labeled as A with a colon, B, or A to B. You can do it like this, you can do it like this, or you can do it like that. Either way, it's the exact same thing. Do it whichever way your teacher does it, okay? Now, in this scenario, B here, cannot be 0. Cannot equal 0, okay? If you have a 0 in the denominator, it will come out as undefined or a insolvable solution, okay? So, whichever way you do it, you cannot have a B. The denominator cannot be 0, okay? All right, and then we have what's called a okay, here we go. So then what we have is a unit rate. A unit rate is a rate with a denominator of 1, okay? An example of a unit rate would be like if you have, let's say you have 60 miles per hour. 60 miles per 1 hour, okay? That is a unit rate. Whenever the denominator is 1, meaning whenever this here, whenever B is 1, therefore that is a unit rate. Hence, that is a unit rate, okay? So, let's get started. Let's say we have, okay, here's an example using unit rates. If this is cost, and this is ounces, let's say you have 72 cents for every 16 ounces, okay? Now, when you or your mother or your father or whoever goes to the store, they buy groceries or whatever, they have what's called a measurement system. And the measurement system in the produce section allows them to buy apples or fruits or vegetables or whatever in a specific type of unit. And the unit will be like, let's say carrots are like, not carrots, let's do lettuce. Let's say lettuce is like 25 cents per ounce, right? That's expensive, but 25 cents per ounce, right? So if it's like 5 ounces, that's 25 cents times 5 ounces, giving us $1.25, right? Okay. So this is the exact same scenario. So if you have the cost being 72 cents, but 16 ounces, all you do is you divide the numerator and the denominator, and you can divide it by 16 because we want to get a unit rate. So we divide by 16. You divide by 16. So you divide points. If you plug it into a calculator, you would get 0.72. 0.72 divided by 16 as a whole number, and you would get, when you plug that into your calculator, 0.045, right? Per ounce, specifically per 1 ounce. Okay. So, being that the American dollar system, the way our funds are set up, we don't have a 0.045 coin, okay? Our system is set up where you have a tens place, a ones place, I'm sorry. Let's just say we have $1.25, right? $1.25. That's its cutoff point right here. You don't go 0.258, I'm sorry, 6, 7, 8, 9, right? It doesn't keep going like that. It stops at that. The lowest coin we have is a penny, which would be labeled as $1.01. That is the lowest denomination of a coin we have, okay? Okay, so that is a unit rate right here. Let's do another one. Come on. There we go. If we have cost being $1.60 per 20 ounces. No, not 20 ounces. Let's do 64 ounces. Divide by 64 on the top and the bottom, and you will get 0.025, which is different from 0.25 because 0.025 is about 2 pennies, and 0.25 is a quarter. Okay, so this is 0.025 per ounce. Okay, so that is how you would do a unit rate. Now, in terms of a proportion, let's see. Proportion, let's do one that involves an equation, okay? So this is a proportion. If we have x plus 4 over 5 equaling x minus 2 over 7, this is easy. When you have proportions, the solution is typically to cross multiply. When you cross multiply, you multiply this top by this bottom and this bottom by this top. So x plus 4 times 7, all we do is we label it out like this. And distribution is key. Okay. So 7 times x and 7 times 4, then 5 times x minus, times 5 times negative 2. 7 times x gives us 7x, times 4 gives us 28, equaling 5 times x gives us 5x minus 10, okay? And then we subtract 5x because we want to get the variables by themselves. And then we get, not 3, 2x plus 28 equaling negative 10. Now we subtract 28 onto the other side. And we get 2x equals negative 38. When you have a negative 10 and a negative 28, you are adding, because think of it this way. If you have negative 10 minus 28, you add the opposite. So this becomes negative 38. So negative 38, we divide by 2 on both sides. X equals, what is that, 19? I think it's 19. Let me check. 38 divided by 2, 1, 2, 1, 8, 9. Yes. Okay, there we go. So, oh wait, I'm sorry, not 19. Negative 19. There we go. Let me do it a different color. Negative 19. X equals negative 19. Bam. All right, next one. All right, so we have chapter 2-5, which is the last section in chapter 2. In this section, let's see. We are basically going over problem solving, I believe. Word problems, basically. The stuff nobody likes to do. Equations and problem solving, that's the name of this section, okay? So, let's do, I'm gonna do number 12 of the check yourself. So let's see. An airplane flies from New Orleans to Atlanta, Georgia, at an average rate of 320 miles per hour. The airplane then returns at an average rate of 280 miles per hour. The total travel time is 3 hours. Copy and complete the table. Okay. So, from, let's say this is Louisiana. I'm sorry, not Louisiana. We're going to call this New Orleans. And this is ATL, Atlanta. Okay. So, going from here to here, and then going back to here, right? So, going from New Orleans to Atlanta, they were going at a rate of 320 miles per hour. Okay, that's the plane going that fast. And then the plane returns at a rate of 280 miles per hour. Obviously, going from Atlanta to New Orleans, they were going slower, right? Yes. So, oh, anyways, 320 to ATL, and from ATL to New Orleans, it was 280. So we set up a diagram. So to Atlanta and back to New Orleans. Okay. So we want to know the rate, the time, and distance, right? All right, cool. Oh, and yes, the last little bit of information was the total travel time is 3 hours, okay? So, what we don't know is, let's see, read the distance, blah, 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 blah. So we do know that the time is 3 hours total. We know that the rate and we know that the return is going to be 3 minus x. The rate is, I'll tell you when we get where we got x from in a sec, okay? So going from New Orleans to Atlanta, the rate is 320. And the ATL back to New Orleans is 280, okay? So, did I say 3? I didn't mean 3, did I? Ha, ha, ha. Figured it out, got it. This part right here is not a 3. The 3, it represents the time that they gave us. It's a total trip duration of 3 hours. Therefore, the original 3 minus x is the original time, the total time, which is 3 hours, subtracted from the time we don't know, which is x, and that itself is why it's in parentheses, because that is a time itself, right? And over here, we assigned x to be the time we don't know, right? Think of it this way. If you got X amount of dollars, X amount of coins and X amount of change, right? And then you have $1.35, and X represents quarters and Y represents dimes. Come on now. Represents dimes. And we don't know either how many coins, so we don't know how many quarters you have or how many dimes. You could just label it as $1.35 minus Y is the exact same as X, or $1.35 minus X is the exact same as Y, okay? That's basically what this is saying, okay? So go back to our situation here. And then the distance apart is simply multiplying this times this times this, and this times that, okay? So 320 times x giving us 320x, and 280 times 3 minus x, so we get 280, I'm sorry, parenthesis 3 minus x, okay? So with that being said, we have, oh yes, and then set these two equal to each other. So now we have 320x equaling 280 times 3 gives us 3, 0, 4, carry the 2, 6, 7, 8. So we get 840 minus 280x. I believe that's right. Let's see. 3 times 200 is 600, and 600 plus 3 times is 240. There we go. Perfect. So now we have a constant and we have two variables. We know how to solve this, right? So now we're going to add 280x to both sides. Add, we get 3, 2, let's see, 0, 0, carry the 1, that becomes 600x equaling 840. Divide by 600. Now we have x equaling 840 over 600. We know that we can cancel out a 0 here and here. Therefore, that leaves us with 84 over 60. We want to simplify this as much as possible. Therefore, x equals, let's see, if we divide this by 4 and divide this by 4, the numerator will give us 21. The denominator will give us, what is that, a 60 divided by 4 is 15, I believe. All right, we can divide some more. Divide by a 3 on the top and divide by a 3 on the bottom. We just want to simplify this as much as possible. 21 divided by 3 bears 7, and 15 divided by 3 bears 5. So you can either leave it as 7 over 5. I'm sorry. We don't want that as our answer. We filled in the blank, yes? We want to check for x and then find out how much time was elapsed, okay? So, excuse me. X equaling 7 over 5 is the exact same thing as 5 equals in 7 one time. Leave the denominator of 5, and that leaves us with 2 over 5, yes? Yes. Now, we want it in this form because we want to subtract it. We want it in that form because we're going to subtract it from 3, which was in our diagram up here, right? So now what we have is x and 3 minus x. So now 3 minus x, x being this right here, 3 minus 7 over 5. We need the denominator of 5, so let's see. Put a 5 there. 5 times 3 gives us 15. 15 minus 7 over, 15 over 5 minus 7 over 5 gives us 8 over 5. 8 over 5. So, the trip from from New Orleans to Atlanta was 7 over 5, so 1 2/5 of an hour. Excuse me. And the return trip was 1 3/5 of an hour. All right. That makes sense because going, remember this one was 320 mph, miles per hour, and this one was 280 miles per hour. So that difference of 40 miles per hour means that it was slower, gave us an extra fifth of an hour to get from one destination to another. Also, basically that is saying, since this was going faster, it took a lower amount of time to get to the destination. This was a larger and a slower speed, therefore it took longer for it to get there. Okay.